Hello students, welcome back to my channel. In this video, I am going to discuss how to calculate the radius and energy of the Bohr's orbit. Students, always remember the fact that Bohr's atomic theory is applicable for the atoms or ions containing only one electron. So, Bohr's atomic theory is applicable for the atoms or ions containing only one electron. Let us know how to calculate the radius of the Bohr's orbit. So, in order to calculate the radius of the Bohr's orbit, we will use the simple formula R is equal to 0.529 into n square by Z Armstrong units. So, how to calculate the radius of the nth orbit, students? That is equal to 0.529 into n square by Z Armstrong units. So, where n is the orbit number. So, n means it represents the orbit number. So, orbit number can be represented by using the alphabets K, L, M, N, etc. Or it can also be represented by using the numbers 1, 2, 3, 4, etc. So, if the electron is present in the L shell, that means it is the second orbit. If the electron is present in the M shell, that means it is present in the third orbit. Clear, students? And Z represents the atomic number. So, Z means atomic number. Let us consider few problems to calculate the radius of the Bohr's orbit. So, here we are supposed to calculate the radius of M shell of hydrogen atom. M shell means, students, it is the third orbit. M shell means third orbit. So, what is the formula for calculating the radius, students? That is equal to 0.529 into n square by Z. So, here the value of n is 3. And here the atom is hydrogen atom. And what is its atomic number? 1. So, substitute these values in the above equation. Then, the radius is equal to 0.529 into 3 square by 1. So, that is equal to 0.529 into 9, and that is equal to 4.761 Armstrong units. Clear, students? So, here we are supposed to calculate the radius of the third orbit of helium ion. So, here the radius of the third orbit of helium ion is supposed to be calculated. So, R is equal to 0.529 into n square by Z. Here n is equal to 3 and Z is equal to 2. So, just substitute these values. Then R is equal to 0.529 into 3 square by 2. So, that is equal to 0.529 into 9 by 2, and finally that is equal to 2.3805 Armstrong units. Clear, students? So, simply the radius of the nth Bohr orbit can be calculated by using the above expression. Let us discuss how to calculate the energy of the electron of nth Bohr orbit. So, if an electron is present in the nth Bohr orbit, we can calculate its energy. So, energy means it is possible to calculate kinetic energy, potential energy and total energy associated with the electron. So let us see the simple expression for calculating kinetic energy, potential energy and total energy. Coming to the kinetic energy, it can be calculated by using the expression kinetic energy is equal to 13.6 into Z square by N square and the unit is electron volts. Coming to the potential energy, that can be calculated by using the expression potential energy is equal to minus 27.2 into Z square by N square electron volts. And coming to the total energy, or simply it can be called as the energy, that is equal to minus 13.6 into Z square by N square electron volts. Why? Here the energy is given with the negative sign. So why the energy is given with the negative sign? Remember that here the electrons are migrating from the infinite orbit to the inner orbits. That means fourth, third, second or first orbit. So when an electron jumps from higher orbit to the lower orbit, what happens, students? So when an electron jumps from infinite orbit to the third orbit or second orbit or even to the first orbit, the energy will be emitted and hence the total energy of the electron will be given with the negative sign. Is it clear, students? Let us see few examples. Calculate kinetic energy, potential energy and total energy of an electron present in the L shell of helium ion. So what is the expression for the kinetic energy, students? That is equal to minus 13.6 into Z square by N square. So that is equal to, here what is the value of Z? Z is equal to 2 and N is also equal to 2. Just substitute these values. Then it becomes 13.6 into 2 square by 2 square. So it is equal to 13.6 and what are the units? Electron volts. Coming to the potential energy is equal to minus 27.2 into Z square by N square. So that is equal to minus 27.2 into 2 square by 2 square. So it is equal to minus 27.2 electron volts. Coming to the total energy, that is equal to minus 13.6 into Z square by N square. So that is equal to minus 13.6 into 2 square by 2 square. So that is equal to minus 13.6 electron volts. Is it clear, students? So by using these three expressions, it is possible to calculate either the potential energy or kinetic energy, even the total energy of the electron present in any orbit. Clear, students? Let us see one more problem. Find the energy of an electron of second orbit of lithium plus 2 ion. So here N is equal to 2 and Z is equal to 3 and we are supposed to calculate total energy. So total energy is equal to minus 13.6 into Z square by N square. So that is equal to minus 13.6 into z square, that is 3 square by n square means 2 square. So that is equal to minus 13.6 into 9 by 4, and finally it is equal to minus 30.6 electron volts. Whenever if you are supposed to calculate the total energy in terms of joules, it is possible to calculate by using the relation, that is 1 electron volt is equal to 1.6 into 10 power minus 19 joules. So that is equal to minus 30.6 into 1.6 into 10 power minus 19 joules. So finally it is equal to minus 48.96 into 10 power minus 19 joules. So we can calculate the total energy of an electron either in terms of electron volts or in terms of joules. Is it clear, students, how to calculate the radius and energy of the any electron present in the Bohr's orbit? Finally, I would like to conclude this video by giving two test questions. You are supposed to calculate the radius of L shell of lithium plus 2 ion, and also you are supposed to calculate the energy of M shell of helium plus ion. If you like the video, don't forget to like, share and subscribe. Thanks for watching. Have a nice day.